the product rule. So since it's log 250 plus log of 400, that plus tells us we're going to rewrite these two logs as one log because we're condensing. And then we're going to multiply the 250 times the 4. Now I'm going to do that in my calculator or in my head. Maybe you want to write down over to the side that we multiplied 250 times 4. And we're multiplying again because the logs are being added. So that's going to give me log of 1,000. Okay? Because the logs are being added, I can condense this down to one log and multiply the 250 times the 4. If they were being subtracted, then I would have to divide 250 by 4. Then can we simplify log of 1,000 without a calculator? Yes, we can. 10 to the third power is 1,000. So the answer simplifies to be 3. So this shows you that it's important to be able to take two logs, write them as one log. Once you write them as one log, sometimes that simplifies. Again, these are just skills that you need to go on to solve log equations in the next section. Example 2, you have two logs, but they're being subtracted. So I'm going to use the quotient rule. So I'm going to write this as one log. You'll write log. You'll write your little base of 3. Either in your head or in your calculator, you'll do 405 divided by 5. And you'll get 81. So those two logs condense to be log base 3 of 81. And then you're going to ask yourself, 3 squared is 9, 3 cubed is 27, 3 to the fourth power is 81. So log base 3 of 81 simplifies to be 4. Okay? It's a lot better than log base 3 of 405 minus log base 3 of 5. Alright, so let's start throwing some variables in. Example 3, log base x plus 7 times log of y. Log of x plus 7 times log of y. So the first thing that I notice is that 7, it's like we're rewinding the film. We're going backwards. So the 7 is being multiplied times the log. So the first thing, either in my head or on my paper, I go, whoop. The 7 is going to go back, and it's going to end up being the power of y. And then since the logs are being added, we're going to multiply x times y to the 7th. It's almost like we're rewinding. Snapchat got that little feature several months ago, didn't it? Was it several months ago? I've seen all kinds of really cute things. My daughter did something where she was standing on a desk and she had all of her Harry Potter clothes on because she's not crazy about Harry Potter, even though she's 28. And maybe she jumped off the desk, but then she did the rewind thing so it looked like she flew backwards. She's just, you got to know her. All right. And you're almost going to go, is that all we do? Well, have you taken a problem that had more than one log and have you condensed it into one log? So you're going from more than one log to one log. You're condensing. And again, if you get really good at this and you understand the rules, you might can do these without any work at all. See if you can do 4 without any work at all. Final answer is ln x squared divided by y to the 1/2. Do you think the book will put y to the 1/2, or do you think the book will go back and change that y to the 1/2 to the square root of y? They like square roots, okay? I don't mind if you leave your answer just like that, okay? But just know that your book may go back and write it as ln x squared divided by the square root of y. And I know we're not supposed to have radicals in the denominator, but I think they let you leave them here because they're just asking you to condense the log. So either one of those answers would be acceptable. Either one of those answers would be acceptable. All right, next example. They're just going to get more complicated. Again, you can do these in a couple steps, or you can start to realize the first two logs are being multiplied. The 4 and the 7 are going to revert back to powers. Okay, so you could actually condense these first two logs. Let's do 2 at a time until you get good at it, and then you might can skip some steps. So this is going to be ln of x to the 4th times y to the 7th. So those first two logs are going to condense down to that one log. And then you still got minus 3 ln z, excuse me. So now I have two logs, they're being subtracted, and I have that 3 that needs to go back to be a power. So since they're being subtracted, this is showing a quotient. What goes in the top? x4, y to the 7th, and what goes in the bottom? Just the z to the 3rd. Now, I have a lot of people that want to put more than one ln. Your job is to get the problem down to one log. So you won't have more than one ln, or you won't have more than one log once you get your final answer. All right, if you want to put this in parentheses, it looks a little bit neater in parentheses. It really doesn't matter. You don't have a power on the outside. That would be the answer. Okay? All right, example 6. Looks like I kind of ran out of room. So let's see if we can do this one without any work at all. Okay, so I know it's going to condense down to one log. Another thing that I know is that I know on the outside of this huge parentheses at the very, very end, once it's condensed, what's the power going to be? 1/3. Does everybody get how I know that? The 1/3 is out in front of all of the logs. So since the 1/3 is out in front of all the logs, then that 1/3 is going to be the power of everything. Okay? So how many logs are being subtracted? 2 logs are being subtracted. Whatever is being subtracted is in the denominator. So you're going to have an x in the denominator, and you're also going to have an x squared plus 5. Since both of those are being subtracted, both of them were in the denominator, and they were being multiplied together to begin with. So the only thing that goes in the numerator is the 5 ln x plus 6, but the 5 is a power, so you're going to revert it back to be a power there. And then so in the top, you're going to have x plus 6 to the 5th. Now for some people, that's just too much at one time. And you could actually do it in steps like we did example 5. Okay? If you do it without any work, just be really, really careful. Okay? But you can actually rewind that problem and make it go all the way back to one log. Alright? Example 7. See if you can do 7 on your own. right, now I did mine in steps. Okay, so for those of you that don't want to do it all together, I took the first two logs. They were being subtracted. I wrote them as a quotient. Then in my second step, I had two more logs that were being subtracted. I forgot the 15, didn't I? The 15 stays in the bottom. Okay? Sorry. And so, and then those two logs are being subtracted. So you write those as a quotient. Now this is not the final answer, but let's see if you have any questions up until this point. If the 15 is in the denominator, then when you put the x plus 2 in the denominator, the 15 will be downstairs with the denominator. All right, questions about how I got to this step? Who knows why that's not the answer? You have two guesses. Guess number one, Mary Frances.
The x squared minus 4 isn't factored, or because we didn't distribute the 15.
Okay. So both of those are actually connected in a way. So x squared minus 4 is not factored, but how does it factor? Let's just do it in our head. X plus 2 and x minus 2, and because one of those factors is x plus 2, then the x plus 2 is going to cancel the x plus 2 in the bottom, and then it would take away your second thought about multiplying by the 15. Okay, so the x squared minus 4 does factor. I'm just going to factor it up here, really, really small. X plus 2, x minus 2. And then the x minus 2 in the bottom is going to cancel with the x plus 2 in the bottom is going to cancel with the x plus 2 in the top, if I can talk today. And your final answer is going to be log. And then you're going to have an x times an x minus 2 in the numerator. And you're going to have a 15 in the denominator. And if you wanted to put little brackets around here because it looks really nice, that would be the final answer. Okay? So you make a decision what's best for you. If you need to do it in little steps, you can do it in little steps. If you want to condense all at once, condense all at once. It's just up to you. I make chocolate chip cookies all the time. I probably made them 5,000 times. I have the recipe memorized. And it always says cream your Crisco, your Crisco, your brown sugar, and your white sugar. Cream that together first, and then who knows what you put in next. Who cooks? Absolutely. I'll have to bring y'all some for Christmas. They're delicious.
You add the eggs and flour.
The eggs and then the...
Chocolate chips.
No. Vanilla. And then you mix all that up. Then you add the flour. And then Ethan, then you add the, at the very end, that's the last thing that you add. I'll have to bring y'all some homemade chocolate chip cookies. They are really, really good if you like chocolate chip cookies. All right, moving on. We're losing track here, Okay, this is where you're going to need your handy dandy calculator, okay? Let's just go straight down to example 8, okay? Just go straight down to example 8, and if I were asking you to evaluate log base 6 of 17 without a calculator, could you figure out what power to raise 6 to that would give you 17? No, because 6 to the first power is what? 6 to the first power is 6, and 6 to the second power is 36. So that means that the answer to log base 6 of 17 would be some power between 1 and 2. But we were just not made to figure that out in our heads. Okay? So we can actually use our calculator, okay, and the knowledge of our calculator in this little formula. Okay? You're going to take your log, okay, and we're going to either use the two logs that are in your calculator. Your calculator either has LOG. Everybody see the LOG button? Okay, you can use LOG if that makes you happy. Or you could use what other button is on your calculator? LN. Whatever makes you happy, either one will work. Are they the same thing? Excellent question. Is log and LN the same thing? No, never, 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 never. Because log is base 10 and ln is base e. Okay? They are both logs, but they're definitely not the same thing. Okay? Now, here's your formula. Who can figure out what this formula is telling you to do?
It's the opposite of base. Like if you were.
Y'all are so tired, aren't you?
Where's the A come from?
Excellent question. That's exactly what I wanted you to ask, Molly. The A is your new base. So you're going to change it to base 10 so you can use your calculator, or do you want to change it to base E? You got to change it to 10 or E because you got to use your calculator to find these answers. Okay? So we want to change it to a new base, and we want to use our calculator. So our new base either needs to be base 10, which would mean we're going to use our LOG button. Okay? So A either needs to be 10, which means we're going to use log, or A needs to be E, which means we're going to use ln. Okay? I just like to use log. You can use ln if you want to. So that means when you set these problems up, you'll have log, base 10 is understood. I don't know why I'm doing that one. Log divided by log. The 10s are understood. Y'all get that? The 10s are understood. You won't see the A values actually written because you're going to use your log, which is base 10. Okay? Then figure out what the big M and the little b is. M in this problem is 17, and B is the old base. So the old base, you throw it away down in the bottom, and 6 goes down in the bottom. You take your handy-dandy calculator. You don't have to worry about putting in the base 10 because if you hit the log button, that's understood base 10, and you do log 17, close parentheses, divided by log again, 6, close parentheses, equal. And we usually have some type of directions. We're rounding to 4 decimal places. 1.5812. I agree with that. 1.5812. Mary Frances is going to make sense of this answer.
And that is the solution of the log?
That is what you're going to raise 6 to. That's going to give you 17. So let's check that. Okay, so let's say you blank out and you freak out on your quiz. So you're going to do, let's check this, 6. How do you get to the power key? The pointy thing, the upside down B. 6 power key 1.5812. So 6 to the 1.582 should be really, really, really close to 17. And it's 16.99858. Why is it not exactly 17? Because we only use 4 decimals there and we rounded. If we use the exact number, we would get 17. Okay? So if you forget that 17 goes on the top and 6 goes on the bottom and you check your answer and it's wrong, swap the numbers. Okay? Alright. So, since you figured out what the formula meant, so on number 9, you're going to do log of 57.2 over log of the old base goes on the bottom, which is 16. Log 57.2, close parentheses, divided by log 16, close parentheses. That is about 1.4595. So let's say you get on the quiz and you just freak out and you can't remember anything. You're going to go back and you're going to check this. 16 to the 1.4595, hit equal. That gives me 57.20225. That means I got the right number on the top and the right number on the bottom. Okay? You can use LN instead of LOG. You're going to get the same exact answer. It just means it's converting it to base E so your calculator can divide and get the right answer for you. Yes?
I don't understand how they would give you the same answer.
What do you mean?
Log and ln.
It's just changing. This formula changes to any base that you want. So if you use LOG, it's changing to base 10 and it's calculating the problem. If you use ln, you're changing it to base e, and it's calculating the problem. It just converts it to the right base, and once you divide, you have two different numbers that you're dividing, but you get the same answer in the end.
I'll just let my calculator understand.
Okay. All right, in example 10, you are not going to use 3.14 because that's a rounded answer, and you're going to only need to round at the very, very end. So you're going to have to find your pi key if you've not already found that. And so you're going to do log of 400, close parentheses, divided by log of pi, close parentheses, equal 5.2340. 5.2340. And again, these are really easy to check. You just got to remember you're either going to change to log or you're going to change these to ln. The old base goes on the bottom, so the other number goes on the top. Check your answer. Make sure your answer makes sense with the original problem. That's how you change a base in order to find an exact value that you cannot find without using a calculator. Questions, concerns, comments? Yes, sir.
Does it get harder than that, or is that it?
That's it.